All right, so you ready for the Kubernetes Guardians? Woohoo! Come on. No? Come on, yeah. So just a small introduction. So I did that talk, this version of a talk, slightly different version of a talk at KubeCon Salt Lake City. And Ben was in the audience, and he was asking security questions, and I'm not a security expert. And I was lost. And at the end, we discussed and say, why don't we run the same benchmark, but he's bringing his own expertise, so he will cover the security aspects in this benchmark, and I do cover the non-security aspects of this benchmark. So if you're up for that, and you want to figure out who is the best security agent, then this talk is for you. So let's introduce ourselves. So we are in a very nice venue. So my name is Lord Observable. I'm a CNCF ambassador.
And I'm just a caretaker here, so I don't know, Ben.
So because the talk is about Avengers and heroes, we had to put our shoes into a hero character. So this is my hero face. I look so nicer in a hero face. And you too, by the way.
Yeah, I love the abs.
So we have same things. If you were there a few minutes ago, I did a benchmark on service meshes. So here it's the same, but with the runtime security agents. You need runtime security agents because at the end it's like a security cameras in your environments to detect suspicious events. So it's very important to have them. But the question is that in the CNCF landscape, there is so many solutions out there. So which one should we pick? So we're going to try to answer that question. So we did it similar to the previous talk. We did lots of benchmark. So disclaimer, nobody has been hurt. We were very gentle with the solutions. And we are not here to criticize the solutions. And the opposite, we want to just figure out the downsides, the good sides of each solutions. And here it's more about sharing you the feedback and how useful they would be. So do you want to, let's introduce the various characters of this movie. We have Falco from the SysDic, the flying runtime agent that is saving the world since many years. Then we have the bees, Cilium, that is well known on the eBAPF landscape. We have KubeArmor, with the shields, it feels that he's going to protect us from dangerous events. And last, we have the wizard, KubeScape, which is Ben. So what are we going to talk about? A couple of things. We're going to see what we expect from those agents. What do you expect really from a security agent? And then we're going to compare, similar to previous talks, on different dimensions. First, we're going to compare it on the design experience, the components that are involved, the observability it provides, and of course, the security angles. And then, of course, at the end, we will share all the results, and we'll have a small conclusion at the end. Are you ready? So this time, I want to have you telling me the chapters. So step 1. Oh, come on, guys. Step 1.
The powers!
Gosh, I prefer that. All right, so what type of power do we need from superheroes? We need a couple of things. We need to be able to capture things. Then we need, of course, components to make that agents runs on the environment. They will provide observability, so we need to make sure that they are healthy and running properly. They need to be performant, because we don't want to have extra latency involved in our applications. And last, they need to do the job. So they need to be secure.
Yeah, at least.
So the components. What do we need? All right. So like every runtime security agent, you need something that detects events into your Kubernetes environments. And for this, of course, the best technology out there is eBPF. So all those solutions will, at the end, have in minimal a daemon set that will deploy eBPF probes. So if you look at the landscape, Falco has a daemon set, the eBPF, and it has the Falco server. We'll touch base why they have it, and it has a specific reason for that. And then there's an optional component called Falco Sidekick, and we'll see that we're going to use it when it comes to observability. Tetragon is similar daemon set. It has an operator, meaning that there are CRDs, and those CRDs will help us to configure the actual security policy that we need. Then we have KubeArmor, daemon set again, the operator, and then it introduced more workload. It has a controller, and it has a relay server. Not sure why they have this, but they have it. And then they have a lot of CRDs. Maybe they have an advantage in terms of performance, so let's see if it brings value. And then we have KubeScape. KubeScape is not doing only runtime. It's doing so much more. That's why those components, you have more things because you're not doing only security runtime. You have the operator, the daemon set, of course, the node agent, that will do the runtime threat detections. They will do vulnerability scans, detect CVEs. It will also have security posture management with Kubescape. So it has so much features. At the end, it doesn't have the same feature coverage than the other solution that we're going to present. And of course, it has tons of CRDs, and we'll see it brings a lot of value behind the scenes. All right. Oh gosh, the energy is very low here. All right. So we need to capture. So we need to capture things, because when you have an attacker, he will probably take control on your container, launch some processes, so spawn some processes, access to files, capture, change privileges, so things like this, you need to capture them. And you need to add, on top of the events capture, some metadata, so like Kubernetes, the path to the process, stuff like this. And when you capture and filter, you are maybe not experts that I am in security. I mean, I don't have the expertise. So having predefined rules is kind of a must, because at the end, we don't have to go through this complicated journey of configuring everything. And then be able to react, block, stop things. That is also a feature that we expect. So let's cover Falco. Falco is not, it's a rule-based engine. By default, it's just a set of rules going through Falco. Falco looks at the rules. Yes, it matched the rules, then it's throwing events. So only throw events when they match the rules that you defined. And because it's well known, they deliver by default a kernel agent that will inject eBPF probes that will capture those processes and files and so on. It has also an SDK, so if you want to, for example, create an SDK that will listen for announcements on the White House at the moment and go through the Falco runtime agent, you can do that because you have an SDK to do this. So Falco capture everything that you need. It has predefined rules, which is kind of easy way of starting. And the difference from the other, it's not an operator, so it loads the rules at the startup of the Falco engine. And then if you need to change any rules, you have to stop the engine, add your extra rule, and then restart the engine. So not having an operator may be kind of a bummer. The structure of the event is well structured. The event structure depends really on the actual rule behind the scenes, so it's not really standardized. So processing those events could be kind of a bummer as well. Then you have Tetragon. Tetragon is basically following a lot on the eBPF side. So it's capture everything that goes on eBPF, process everything. By default, if you deploy it, it will capture every process execution and process exit. And then if you deploy a policy, then it will throw events extra on top of those process executions. The way you configure it is through trace points, kprob, so kprob kernel functions, trace points, kernel events, uprob, user functions, and LSM. So the way you do it is like you have a tracing policy. So this is where you need an expertise on the kernel. So which functions I want to capture, how I'm going to parse it, so which index of the functions on the C level I want to parse. So if you don't know that, then it's kind of difficult. They don't have any predefined rules, so that is also kind of complicated. And then they have the options to block or react. So at the end, Tetragon is very, very advanced. You can do tons of things, but you need a certain level of expertise to handle it. KubeArmor is not producing any events by default. So if you want to have, it will only produce events if you deploy a policy, and if the policy detects something related to that policy, then he will throw events. But by default, if you want to configure the policies, it's quite complicated. So that's why you have the options to turn on events. So you have an annotations from the operator where you can say, oh, I want to have details about the file, or the processes, or the network, or capabilities. And once it's enabled on a namespace, then it starts producing events. So, it doesn't come with predefined policies, so you will have to configure everything by yourself. It has a repository with predefined policies, but again, there's so many of them, you're a bit lost. Which one should I pick? Which one should I customize? This is the big questions. And then they have lots of CRDs, so the KubeArmor cluster config for the cluster, the KubeArmor policy for the namespace or the workload, and you can also define one specific policy just for the host. Maybe one CRD will be a bit simpler for the user instead of having all of them. One advantage I would say from a KubeArmor perspective is that the event produced is super well structured. Every event will be the same way, so parsing it is super simple. And then defining a rule, then again, you need to have a certain level of expertise to see which process should I pay attention, how should I filter, and so on and so forth. Then you have Kubescape. Kubescape is completely different from the other vendors. They took a different angle, and I think when Ben reached out to me and explained it, I said, wow, that's so smart. So the way it works is that it will only produce events that is suspicious. And when you deploy it, you don't have to configure. Everything is already enabled. And the way it works, it has a learning phase. So the node agent that is deployed, that has the eBPF probes, will learn the application, which processes is used, which capabilities, which user, everything that you know, and then keep track on this. And everything there's a change, oh, something is different. There's a new process in the container now. It sounds suspicious. So he will basically raise an alert, say, hey, that doesn't sound normal. So that I think is a smart way because you don't have to go through this painful configuration. And then the other thing is what I like is that there has this runtime rule alert bindings where it's just toggle which rule I want to enable or disable. By default, you have every rules enabled, and it doesn't just capture the suspicious events on your runtime. It does also detect malware scanning, also any well-known security vulnerabilities that could happen in your cluster. So it does a lot of things behind the scenes. So in terms of user experience, you just deploy it, and you know that you will have alerts produced when they are dangerous. So for this, I would say from the summary of this, only Kubescape and Falco has the default policies, which is great. They, of course, capture everything that you need. The only one that's able to react on something is KubeArmor and Tetragon. And the only one that can customize, I would say, is Falco because they have an SDK. And Tetragon, you don't have SDKs, but the way the policy works is so advanced that you can do tons of things. It's impressive. And I think you have an SDK, no? Or?
Yeah, we do have an SDK, and you can go packages and so on. So you can customize rules, but you have to write code.
Yeah. All right, so that's covered the first piece. Let's move on to observability. Okay. So what do we expect from observability? So those solutions capture events. So by default, it extends the observability. You know problems, so you can collect those events through logs or open telemetry. You can parse those logs easily. They are going to be very noisy, depending on the solution, so you need to limit them somehow. You need to throttle, because if you have thousands of events, and it's going to be just putting a lot of noise everywhere, so you need to be able to throttle. And then the last piece is that you are deploying something, you want to rely on it, so you need to make sure that they are healthy. So I need to know that those operators are running smoothly and properly. So Falco has, they produce not the events on the agents, they produce it on the runtime server, so you have to parse it from there. The events is not structured, that's why you need to deploy Falco Sidekick that will pre-parse the rules. And then it also exposes a lot of metrics about the health of the agents, of the operator, and so on. Then you have Tetragon. Tetragon has, of course, the events is super rich. You can throttle, you can do whatever you want behind the scenes. And the operator exposes tons of metrics about the agents, about the operator, so you know that it's running smoothly or not. You can at least figure out, put alerts, and react. Then you have KubeArmor. Because KubeArmor, it doesn't produce logs at the agent level. It does it only on the relay server, so you have to collect it from the relay server. They have also an open telemetry receiver, which is nice, but it's not been maintained, so it's a bummer. So it would be great to maintain it for sure. But then, in terms of how healthy the operator is, you don't know. There is nothing exposed. And I know that the project is running on adding that feature soon. Kubescape, on all the features covered, not only in runtime, they produce OpenTelemetry logs, metrics, traces. They have metrics on the node agents. They have tons of things. So you can know exactly everything without any major effort. They also have CRDs with all the scans that they're doing. So if you want to have the details, you can just do a describe on those objects, and you got the full-fledged details. So it's amazing. So in terms of observability, I would say that except KubeArmor, everyone has the right things. KubeArmor doesn't have metrics about your policy that you deployed. It doesn't provide any health metrics about the operator. So the only ones that do that is the other solutions. And now,
security.
Thank you. Thank you that I didn't need to do this, like helping me. So, so again, I want to reiterate from a security perspective, like the major differences between these libraries. Like all, as Henrik said, like all of these are great open source projects, and we are providing feedbacks. And as a maintainer of Kubescape, like obviously I might not be objective here enough to like make claims. But having said that, since I also contributed to Falco in the past, so I really love all of these and projects. So I do want to point out the differences in the design concept. So one, again, Falco is the oldest from my perspective. It has a lot of mileage. It's deployed in a lot of places. A lot of rules being developed. Great. You know, KubeArmor. I really love about KubeArmor the option that you can really define prevention rules. It's super cool. It also, you can do that to some extent also with Tetragon. But one of the greatest things about Tetragon is that you are able to do rule evaluation within the eBPF itself, which also helps from a performance perspective, as opposed to Falco. Falco is like super doing all this processing in the user space, and it costs a lot of CPU and memory to like transfer this information to the user space and do the decisions, and Tetragon is doing back in the kernel. And Kubescape really took a different approach, like in trying to like adding the idea of like learning and profiling applications and using them in detection is a really different approach from the others. So what I'm going to show you today is a command injection attack, where during the, when we talked about the test methodology, we said, okay, we are going to test all of these projects through a specific attack. In this attack, we've spun up an application within a container Kubernetes cluster. It receives the traffic through an ingress, and the attacker is exploiting a vulnerability in this application, which enables the attacker to inject commands into the container and execute arbitrary commands within the container. It's a vulnerable application we've developed for this purpose. And to show you how it works, this is the application. You can just like ping IPs with this application. Super cool, very useful application. Now, what you can do is, like as any security engineer would do, as the first thing it tries to do is like a command injection, like putting a semicolon and an ls. And when I'm trying to ping, it turns out that actually the ping itself is, the ls is concatenated, and you can see that it was executed within the container. Again, this is a deliberately vulnerable application, but this is actually copied through a real vulnerable app. Now, we are going to do something more interesting, and instead of just doing an ls within the container, we are going to steal here the service account token within the container. Now, just like cutting it out and getting the response. Now, the reason for doing this test, because it emulates a real attack on a cloud-native application. And we expect these components to detect something on these. And we've tested all 4 projects under this attack. You can see that here we've been able to extract the service account token from within the container. So, and now I'm doing like a side note here, because most likely I'm going to be killed if someone loves Falco or KubeArmor. What I did is I've installed everything and used the default settings, default installation. Okay, now you can say that, well, you can fine-tune everything, and I have, it's hard to admit, but I have like 20 years of experience in the security field, and every project and every security detection agent will claim to you that had you did this configuration, I would have detected the attack. I myself claimed the same thing a few times. But it's really hard to compare these projects if I'm starting to fine-tune each of them just to detect this thing. So I've used the default configurations from each of them. So for Falco, we got 6 detections on a shell that was spawned by untrusted binary. It wasn't completely clear for me why untrusted binary, but in general, it indeed detected that there was a shell that was spawned, which is okay. Unexpected connection to Kubernetes API server. It was in this very specific case, it was true. To tell the truth, it's not really, it's not a very good rule in my perspective, but in this case it worked. And critical executing a binary not part of this image base was true because I indeed run application executable outside the container, and it's a great detection. But I also got 900 unrelated alerts. So if I'm looking at the signal to noise ratio, it is okay, detected the right things, but I get a lot of other detections. So regarding CubeArmor, again, default settings, I didn't really get, like, except of detecting all the exec events, which were either true or not true. They weren't really good. And I got 486 alerts, a little bit too much. Tetragon also detected exec events and exit events. Not real good. Again, sure, I could start to fine-tune Tetragon, but it was like, you know, it's a different project, like when I start to configure each of them. So within Kubescape, we really detected you know, the exec binary, which was not part of the base image, the service account token access, which wasn't expected, and all of these. Note that the unexpected word in these alerts means that it was, the behavior was not part of the learned behavior of the application, which is again a way for us to filter out false positives and try to point into real positives in the environment. And from my perspective, there were no false positives, which is kind of cool. So the conclusion on the security side is that there is like an obvious difference between how Tetragon and CubeArmor is working and how Falco is Kubescape. Falco and Kubescape, from my perspective, are more security engineering oriented. In order to, as a security engineer or operator, in order for me to use Tetragon, I need to learn so many things about Linux and policies and stuff, and also about CubeArmor, that it's a lot of things to ingest for someone who is not in this field too much. Tetragon and CubeArmor are able to block system calls, while Falco and Kubescape cannot. And we have, in Falco and Kubescape, obviously, we had a lot of detection rules. From a noise to signal ratio, I don't really want to talk about CubeArmor and Tetragon, I guess, because I don't feel it's fair with them to talk about this when I didn't do any fine-tuning in the configuration. But Kubescape's really the concept of using application baseline profile is really helping to filter out irrelevant alerts in our case. And as a summary, from a security perspective, again, when installing these vanilla things, I think that Falco and Kubescape were the leaders from this perspective.
Okay, cool. So to measure the performance, same thing. I wanted to measure the latency that they introduced to the applications, and then the actual resource usage, so CPU usage, memory usage, and then because it happens on the kernel side, and if you just look at the user space, you don't know actually what happens. So that's why I also measure the ABBF footprint of those agents. To achieve that, I did the default settings from Falco and Kubescape, and then I deployed some policies for Tetragon and some policies for CubeArmor. I did a lot of tests, so no agents, like before, and then Falco with policies and without, they have the policies, so you don't have to do this. Tetragon without the default events, then Tetragon with the events and policies, and I did the same for the others. Kubescape I didn't have to do because it has the default policies enabled. Here is the QR code to the environment. I have different applications that make suspicious attacks, plus the OpenTerm demo that will be used to measure the actual latency. And then I have Inspector Gadget to measure the eBPF footprint. So let's look at the results. So I will only show the constant load because I think the load test doesn't bring any difference. So I have two types of tests, so constant will be only used. In terms of latency introduced, the most efficient one was Tetragon without any policies deployed. And then it's going to be Falco, CubeArmor, and Kubescape. But here Kubescape, remember, they don't only do runtime, they do more features in the security space. In terms of usage, memory usage, the Kubescape does, of course, consume more because it has full-fledged features enabled. And from the CPU, it's Falco consuming the most. On the eBPF side, it's going to be the CPU is going to be Kubescape on the higher end, and then Kubescape as well on the memory side. Now let's enable policies without events. So here you have, you can see that CubeArmor is the same response times with only doing runtime detections. Tetragon, same thing, and then Falco is still at 3 milliseconds. And then from the CPU usage, you can see that now we start to see CubeArmor consuming a bit more. On the eBPF side, it's basically changed as well. We start to have what is this color? You don't see that color. That's true. It's a good reference. So it's Tetragon. It's Falco that consumes a bit more, and the other one is still Tetragon. And then if I start to introduce events, because you can enable events in those products, then you can see that CubeArmor suddenly starts consuming way much more. And then if you look at the eBPF probe, the usage of the actual eBPF probe starts to do more things in the kernel. So that's why you have impact on our application. So in terms of conclusion, in the latency, Falco is a beast, 3 milliseconds. But then you only do runtime, where Kubescape does more features coverage. In terms of CPU consumptions and memory consumptions, I would say that Falco is consuming a bit more CPU. And on an eBPF side, Kubescape is consuming more, but again, it has more features involved when you enable it. So in terms of conclusion, I would say Kubescape, without any effort, gives you the full-fledged features, and it covers pretty much everything. I think Falco is doing a great job, but if you're looking for solutions doing blocking, it's only the engineering side of the game, which is CubeArmor and Falco, who is providing those features. But I would say if you don't want to go to the easy, complicated route of configuring everything yourself and learning all the kernel tricks, then I would recommend using Falco and Kubescape for sure. That's it. And again, it's small teaser to the channel where there is an episode on Kubescape that I released a few weeks ago, episode on Falco and each of those solutions, and I may probably update this benchmark soon as a video as well. If you have any questions, we will be very eager to answer your questions.
Would it be possible to use multiple of these products at the same time?
I think it does. I would say those products are injecting eBPF probes and they are consuming more things in the kernel. So you should be cautious about the number of probes that you put on your system. I think if one is doing a great job, then let's use one solution. What do you think?
Yeah, you can do it. Like, there is no technological limit to that. I would say it's not really like useful. Like, most likely you won't need, like, big organizations I've seen using eBPF at scale, they are like maybe one thing for security, maybe a second agent, an eBPF agent for networking / maybe one for, but no one will be ready to like do like 2 agents for security, or you maybe get away with like if you're labeling one thing for security, one thing for observability, but that's all.
So in your example with the vulnerable application, all you did was to...
Can you just speak up a little bit?
Yeah, so in the example with the vulnerable application, all you did was to output the token, the service account token, but then in the words we saw some DNS requests and binary executed, so what we didn't see?
So, I would love to show the whole test to you. I was thinking of just like it was too complex to explain the whole thing, but as, beyond only like stealing the access token, I've also downloaded a kubectl into the pod, do the chmod plus X to make it executable. Then I started to do get pods through the command injection, and this is why you've seen like multiple things in the environment. If you want to try this, I can show you where it is in GitHub, and it's a public attack.
And then the same thing here, the Goat app here is doing also same things, trying to access a container, do some process spawns and so on.
Yeah, thank you for the interesting talk. It was a very nice comparison. I was wondering, yeah, there are other open source tools doing similar things, for example, NeuVector. Do you have any experience with NeuVector?
I just used Tracy from Aqua Security, but I don't know this product.
I know NeuVector to some extent, like a year and a half ago. I don't know what new things. So NeuVector is, I would say, is also able, if I remember correctly, NeuVector is also able to block due to policies, different things. NeuVector is also had a learning period, if I remember correctly. But I think it was introduced like a half year ago or something, maybe, if I'm not mistaken. I don't know it really well. So we didn't have a chance to look into NeuVector more deeply. It was something of an outlier for us because we try to focus more on CNCF stuff.
Thank you.
Thank you, Ben. Thank you, Henrik.
Oh.
Anybody else?
Great, awesome. I love questions.
Are there any tools here or highlights that we should be aware of in trying to learn in one cluster, in a staging cluster, and then use those rules in a production environment?
I love this question. It wasn't premeditated though. There is usually there is a problem here sometimes because it's not easy to do this kind of learning and configuration and then moving from one cluster to another, because there are sometimes differences of how the dev cluster operates and how the prod cluster operates. Now again I'm subject. Don't take my word. But from Kubescape, we designed Kubescape. So, and everything is a CRD in Kubescape. So when we learn a behavior baseline, when you configure a rule, everything is CRD. So you can just push it to your Git after you learned, and just roll it out together into production. And actually, it's working. So it's working more or less nicely. Obviously, there are caveats here. For example, endpoints, DNS endpoints, which are different from dev to prod, and there has to be a few things that have to be updated manually if you want to do these things over the top. But I would dare to say that 90% can be simply just rolled from dev to prod.
And it's time. So if you have any other questions, go ahead and bug Ben and Henrik.
Thank you very much.
Thank you.